Okay, so slopes of parallel lines. What we're going to talk about today is what we know about two lines that are parallel to each other. So I have a question written out here that we're going to look at in a second. But before we do that, I want to talk about a couple of words that we need to know. The first one is parallel. Okay, this means two lines side by side that never touch. Okay, so these two purple lines are parallel to each other, sort of. These two yellow lines are parallel to each other. These two blue lines are parallel to each other. In any situation, if I kept drawing out these lines and I extended them in either direction, they would never cross, okay? The opposite of parallel is perpendicular. Now, perpendicular lines meet at a 90-degree angle. So these purple lines are perpendicular. These yellow lines are perpendicular. And these blue lines are perpendicular. There is a 90-degree angle in all of those examples. So perpendicular lines cross at exactly 90 degrees. Okay? So that's parallel and perpendicular. Slope, again, just so that we remember here, slope is how steep a line is. Okay? So if we go back down to this question here, it says, is this line segment with endpoints -1 and 4 and 3 and 6 parallel to the line segment with endpoints 6, 5, and 2, 3? So let's draw a graph so that we can see what this question is telling us first. So in my graph, do my best to make this as nice as possible. Okay. My first point, my first line I'm gonna do in red here. So -1 and 1, 2, 3, 4, that's my end point, okay? So that's one end of the first line. And the other one is 3 and 6. So 3 and 1, 2, 3, 4, 5, 6. So the line goes through this one like this. I'm gonna fix that so it looks nice. The end points must touch where those dots are, okay? So just so we're clear, that is an end point. And this one was 3, 6, and this end point was -1, 4. Now we're gonna look at this second line here, and I'm gonna put this in blue. So my first point was 6 and 5. So 1, 2, 3, 4, 5, 6, up 5, 1, 2, 3, 4, 5, and 2 and 3. So 1, 2, 1, 2, 3. And I'm gonna draw a line connecting those points. Perfect. Now, looking at this, the lines look fairly parallel. Okay, they look almost like they could be parallel. But the way we need to tell is parallel lines will have the same slope, but different y-intercepts. Okay? So let's calculate slope. So slope equals y2 minus y1 over x2 minus x1. And my other line, my blue line, will be slope equals y2 minus y1 over x2 minus x1. And I'm going to plug in the values for each of those. So my first one, I'm going to number this one 1 and this one 2. So my y2 was going to be 6 and my y1 was going to be 4. And then my next one for my x's, my x2 is 3 and my x1 is negative 1. So 3 minus negative 1. Okay, so the slope of my red line is 2 over 3 minus negative 1, which is 4 or 1/2. Does that make sense? Finding slope? Okay, let's do the blue example here. So we're going to label this point 1 and this point 2. So slope equals my y2, I'm going to rewrite the points here. So this was 2, 3, and this one was 6, 5. So my y2 is 5, and my y1 is 3. So 5 minus 3. And then my x2 is 6, and my x1 is 2 over 6 minus 2. Okay, so then the slope for this one equals 2 over 4 or 1/2. These have the same slope. Blue slope is 1/2, red slope is 1/2. So my red and blue lines are parallel with a slope of 1/2. And that's how we can determine if something has parallel lines. So we can either calculate slope or we can find out from a graph. Okay.